Today we're talking about probability and compound events. Okay, first thing we're talking about is compound event that's made up of two or more simple events. Okay, compound meaning made up of two or more simple events. If the outcome of one event does not affect the outcome of the other, all right, then this is what they call them independent events. Okay, if one doesn't affect the other. All right, to figure the probability of independent events. Okay, so the probability that A and B will both happen, you take the probability of A times the probability of B. Okay, so you just multiply the two probabilities. All right, everybody have this written down. All right, so we have a bag. It contains 6 black marbles, 9 blue, 4 yellow, and 2 green. A marble is selected, put back into the bag, and then a second marble is selected. Okay, so we need to find the probability of selecting a black marble and then a yellow marble. Now this is independent, okay, because what was selected first does not affect the second one. Okay, because all of them have been replaced. So we need to find the probability of selecting a black marble and then a yellow marble. So we need to find the probability of a black marble. Then we need to find the probability of a yellow marble. Probability of a black marble. First thing we need is we need to see how many total marbles are in a bag. So we need to add them up. 6 and 9, 14, plus 4, 18. Oh yeah, you're right. 15. Okay, plus 4 is 19. Plus 2, 21. So we have 21 marbles to pick from. We need a black one. How many black marbles are in a bag? 6. So you have a 6 out of 21 chance of getting it. Alright, now we put the black one back in the bag. We're trying to draw for a yellow one. How many total yellows are in a bag? 4 out of how many total marbles? 21. Right, now if they're independent events, which this is because they don't affect each other, right, then we multiply them. So we take 6 times 21, times it by 4 over 21. 6 times 4 is 24. 21 times 21 is 441. Right? Then what you do, okay, you take 24 divided by 441. To find that is a 5.4% chance. Right? You get 0.054. All right, change it to a percent. 24 divided by 441. You get 0.054. Change it to a percent. Any questions? All right, so you write P, blue, green. All right, leave some spaces. Then we're going to find probability of a not black and then a blue. All right, so we need to find probability of drawing a blue one and then a green one. All right, we're still drawing out of the same bag. That's 21. How many blue were in the bag?
9.
9, right? We're going to times that with how many are in the, or how many green are in the bag? How many green? 2. So 2 out of 21. So I have 18 over 441. Right? Right, we divide that, change it to percent, you get 4.1%. Because it's dark in here. Alright, now we need to do probability of not a black one and then a blue one. Okay? We have 21 total. How many black were in the bag? 6. So how many are not black? 15. Alright, how many blue were in the bag? 9. 9 times 15. So 135 over 441. Alright, if you divide those, you get, and then change it to a percentage, you get 30.6%. A little less than a third of getting those two in that order. Any questions on how to do that? All right, you need to write this down. This is the definition of dependent events. Okay, like I said, dependent events, if the outcome of one event affects another event, okay? So like before, you pick the marble, then put it back. This would be where you pick the marble and don't put it back. That's going to affect the rest of the ones picked, right? Because you got one less marble. So probability of dependent events, okay? Where you have the probability of A and B, you take the probability of A times the probability of B following A. So B is being affected by A. Alright, so you need to write this down. It says that Henry randomly draws 3 cards one at a time without replacement. Find probability that the cards are drawn in the given order. Okay? So this is a dependent event because the first card will affect the second card drawn, right? Because you can't draw the same card twice. Alright? And the third card can't be one of the first two. So I need to find out what the probability of drawing a diamond, then a spade, and then another diamond. Okay? Probability of a diamond. Right? Does anyone know how many diamonds are in a deck of cards? Okay. Does anyone know how many cards are in a deck of cards? 52. Okay? 52 divided by 4 because you have 4 suits, right? 52 divided by 4 is 13. Okay? So the odds of drawing a diamond is 13 out of 52. Okay? Or 1/4. Okay? So that's probability of a diamond. Probability of a spade. Right? How many spades are in a deck of cards? 13. How many cards do we have left? 51 because we took a card out, right? So that's the probability of drawing a spade. Now I need to figure out what the probability of drawing another diamond. How many diamonds do I have left?
12.
12?
Out of 50.
Out of 50. Okay? Now, we just multiply these together, right? So 1/4 times 13 over 51 times 12 over 50. Okay? If you want to do some reducing, you can. Okay? Then you take 13 times 3. And you get, well, you actually do all that work and then reduce. It works out to 13 over 850, which, when you do the division, 13 divided by 850, you get a 1.5% chance. Yeah. So we need to find the probability of drawing a 4. Okay, how many 4s are in a deck of cards?
Like 34.
35.
25. No, 16.
40.
There's
No, 16.
4 of them.
What? No, there's not.
Yeah,
there's because there's 4 for each one.
There's 1 4 for each suit, right? Yeah. Okay. So if I did draw a 4, what's the chance? How many 4s would I have left?
2. 3.
3, right? Okay, because we're assuming that we actually got it. Okay, we're saying if we got it. Okay. Well, probably not. That's why the probability is really low. Like before, it was a 1.5% chance. Really low, right? Okay. But we're saying if you did, then you would have 3 more to pick from out of 51 cards. What about not a jack?
13.
Okay. How many cards? What would be the bottom? What would be our? There'd be 50 cards, right? How many cards are not jacks?
There's 4 that are.
There's 4 cards that are jacks. So 4 out of 50 would be what? 46. Because we've already, now, technically it would be 48, but we've already drawn 2 cards from this deck, haven't we? Right? Okay. So now we just multiply these. So 4 times 4 over 52 times 3 over 51 times 46 over 50. That comes out to 23 over 132,600. Oh, actually, no. I was looking. Okay, it shouldn't be 23. It should be 552. Okay. Which reduces the 23 over 5525. Okay. You work that out. It's a 0.4% chance. So you don't even have a 1% chance of making this happen.
How long did you get? 5 then?
Maybe not. It ain't 4%, it's 0.4.
0.4. Okay. Any questions on how to do that? All right. You need to write this down. This definition of compounding events that are mutually exclusive means they cannot occur at the same time. All right. So mutually exclusive events that cannot occur at the same time. So in a deck of cards, it'd be like drawing one card. Okay. So this is one event, right? It'd be like either drawing a diamond or a spade. It can't happen at the same time, right? Okay, so this is one event. Probability of A or B happening. Okay, you find the probability of A, you add it to the probability of B happening. Okay, so mutually exclusive events that cannot happen at the same time.
No.
All right, so we have this: a die being rolled. Okay, find each probability. When you roll a die, can you have a 3 and a 5 show up at the same time? No. Okay, it's one event. It can't have two different outcomes, right? It only has one outcome. Somehow Cameron has a die. Okay. So if I rolled this, right, we need to find a probability of a 3 or a 5.
Snake eyes.
Okay?
Yeah.
What we need to do is we need to find a probability of rolling a 3. We need to add it to the probability of rolling a 5. Well, okay, there are 6 faces. 3 is on one of them, right?
Yeah.
There are 6 faces. A 5 is on one of them. So what we need to do is we need to add these. So we need to add these two fractions. These are like fractions, 6 and 6. So we just add the numerators. 1 plus 1 is 2. 2 6, which equal to 1/3. Right? If we find a percentage, it is 33% chance. Okay? So it's a 33% chance that when Cameron rolls his dice, it'll be a 3 or a 5. It was a 4, so he lost. Okay? It's 2, he still can't do it. Alright, you need to write P at least 4. So we need to find a probability of rolling at least a 4. Alright, so probability of at least a 4. I need to find the probability of a 4. Alright, I need to find the probability that we roll a 5. And I need to find the probability of rolling a 6. Okay, because it has to be either a 4, 5, or 6. Right? Okay, probability of a 4 would be 1 out of 6. Probability of 5 would be a 1 out of 6. Probability of rolling a 6 would be a 1 out of 6. Alright? Now, so we add those. 1 plus 1 plus 1 is 3. So 3 out of 6 chance, which same thing as a half. So we have a 50% chance of rolling at least a 4.
How come we don't add the...
Events that are not mutually exclusive, meaning that A or B could happen, okay, or A, B could happen, okay, it could happen at the same time. What we do is we take the probability of A, we add it to the probability of B happening, right, and then we subtract the probability of A and B happening at the same time.
Correct.
Okay? Alright, so you need to write this down.
Oh my god.
Of 240 girls, it says at a school, 176 are on honor roll, 48 play sports, and 36 are both. They're on the honor roll and play sports. So what is the probability that a randomly selected student plays sports or is on the honor roll? So what we need to do is find what's the odds that one of them will be play sports or is on the honor roll. So what we need to do is we need to find probability of playing sports. We also need to find probability of being on the honor roll. Then we need to find probability of both. Okay? So, sports, how many play sports?
48.
Out of how many girls?
240.
240. What's the probability of a girl being on the honor roll?
So 176 or...
176 over 240. What's the probability of both?
36 over
240. Okay, what we do is we add probability of A happening or probability of B happening, and then we subtract the probability of both happening. So we take 48 plus 176. Then we're going to subtract 36 from it. Okay, because these girls are included. The 36 out of 240 is included in either sports and in the honor roll, so we don't need to include them. Okay, so 48 plus 176, okay, minus 36, you get 188 over 240, which reduces to 47 over 60. Right? Once you have reduced it, or you can just go ahead and take 188 divided by 240, you find that it is a 78% chance of occurring. Alright, here's your homework. If you guys don't want to work, I will add to it. Now, here's what you do. 1 through 8, it'll ask you to identify, is this independent or dependent, or mutually exclusive or non-mutually exclusive. Okay? And then you'll have to find the probability of it happening.